Hi everyone, welcome back to my channel. Today we are going to learn about dense retrieval and BM25. Dense retrieval has a blind spot. Dense retrieval is based on semantic search. When we are converting chunks into vectors, these vectors are present in the vector space, and the distance between the vectors decide how similar or different their meanings are. Vectors that are close to each other have similar semantic meanings. So semantic search understands synonyms, paraphrases, or cross-language queries because they have similar meanings, so they are placed closer. Vectors that have different meanings, so the words that have different meanings, are placed farther away from each other, given that they are not semantically similar. They work well when we are looking for synonym-based search. Say, if I ask when will I get my money back? So it's supposed to point to a refund policy document. But if we have something related to an order ID, order numbers don't have any semantic meaning. So that's a blind spot for dense retrieval to analyze or give better scoring about retrieval. We have another algorithm called Best Match 25. This works well for exact product codes, model numbers, or domain jargons. So it is basically based on traditional TF-IDF, but it is better. That means it scores the words that are frequently appearing against the weightage of how rarely those words appear in the full corpus. So with document length normalization, it prevents long documents from getting more priority or dominating the whole scoring here. Here, BM25 fails for synonyms or paraphrases because it does not look for semantic meanings. It does mostly exact word matching. It's good for order numbers or any specific codes. Neither alone is sufficient because dense retrieval is mostly working for meaning, synonyms, and paraphrases, whereas BM25 does exact matching. So either one has a weakness. And another thing is the scoring type in case of dense retrieval is cosine similarity, so it ranges from -1 to +1. Whereas BM25 is an unbounded positive number. So we cannot combine both of them if you want the best match. But just doing average or addition. So let's see how it is done. So here comes the concept of hybrid search, where we are going to combine both the kind of retrievers, where cosine similarity and BM25 scores, where they're living on different scales. We are going to combine them using a metric called Reciprocal Rank Fusion, or RRF. Reciprocal Rank Fusion does not consider the scores itself to calculate, it considers the ranks. So the formula is summation of 1 by k plus rank I d. Here k is an empirically stable constant. We are going to set this to 60 because it prevents single rank 1 result from dominating the finalist. So in order to keep it balanced, we're going to keep k constant as 60. And rank D is the position of document D in each of the rank lists. Where is the document being ranked? So we are not going to tune K. It works robustly across retrieve tasks out of the box. Say we suppose a document is ranked 1 in both the lists, so it scores highest. So it's very consistent. So we are going to get higher hybrid retrieval score, whereas it ranks 1 in dense retrieval and somewhere ranks 10 in BM25. So the score is going to get slightly lower. So it's going to reduce the confidence because of mixed signals. In production, services like Elasticsearch, Azure, Cognitive Search, AWS, all of them are using hybrid retrieval as their default. So the question for us is no longer should I use hybrid or not. So the question here is how do we implement it correctly? I would like to give an example of my project that I'm working on. It's for an e-commerce website. It's a FAQ agent. or customer success agent. Here, if we give a query like, when will I get my money back? If I'm using dense retrieval to evaluate, my hit rate is going to be much higher because I will find document, say, refund policy that has the exact refund policy details. Whereas if I evaluate using BM25, my hit rate comes down to 68% because the exact words that are being matched here are money and back, where any document that has word money will be ranked higher. So in general, the refund policy document does not come up higher in the space. When you're trying to do the retrieval, it does not come up very high in the top K chunks. So that's a problem that we're going to solve using re-ranking, which will be my next video. Thank you so much for watching my video. Support my channel. Bye.